Well, that was just an interval, so now let's just go through and do a test so you can see how similar and different they are. All right, suppose we want to test the hypothesis. That's your clue that this is a test. I don't like that box. Test the hypothesis. Test, that's how you know that beta blockers reduce the mean pulse rate. Run an appropriate is another clue. It's a test at the alpha equals 0.05 level. Okay, so we are still working with those same x bar 1 was, I don't remember, 65.2. S1, I still don't remember, 7.8. And 1 was 30, I know that. X bar 2, I know it was 70 something, 70.3 and 8.3. All right, so we just need those numbers again, and then now we'll get started with our pass. So start off, procedure name, to sample. We're always doing T for means at this point. Test for mu1 minus mu2. All tests have an HO and an HA. For all two sample things, our HO will be that the mean for group 1 is equal to the mean for group 2. That means no difference in the treatments or in the two groups. And another way we write that is that mu1 minus mu2 equals 0. So that's just some background information. And then before I get to my HA, I like to go ahead and define my means. So my mean 1 is true. I'm doing it again even though we just did it on the last page, but I really just want to make sure that it's clear here. True mean pulse rate. The board is being slow. It does this in class too, so it's actually pretty appropriate that it's happening on this video. So we'll just give it a break. You guys probably need a break too. All right, true mean pulse rate. Always does this. Nope, not ready. We'll just move it around a little, give it a tiny bit of a break. Okay, ready. True mean pulse rate of heart surgery patients receiving the beta blocker and Mewtwo, our Pokemon friend. I'm just going to put ... not receiving the beta blocker since we've already done it on the confidence interval question. Okay, so now that I know that my mu1 is the beta blocker group and we're wondering if the beta blockers reduce the mean pulse rate, that helps me decide on a less than sign. If I had switched around my labels, my inequality would also change. You just have to pay attention to the problem and which one you designate as which variable so that you can put the right inequality for your HA. All right, that's all that goes in the P. We have our procedure, our hypothesis statement, and our parameters defined. Now we will do our statistic or our assumptions and conditions. All right, same three: random, normal, independent, but we're going to add in the alpha level. Alpha equals 0.05. And I'm just going to put that we checked in number 1. They're the same conditions. Nothing changes about them, and we do not need to check them again. All right, S. S stands for statistical work. In a test, we need two items in our statistical work. We need our test statistic, t equals x bar 1 minus x bar 2 minus 0, since your null is always no difference between the population means. And then we have our same standard deviation, S1 squared over N1 plus S2 squared over N2. All right, let's fill it in. That is going to equal 65.2 minus 70.3 minus 0 over the same standard deviation I used in my interval, but I still need to show my work. 7.8 squared over 30 plus 8.3 squared over 30. All right, let's calculate what that is on the calculator. 65.2 minus 70.3. I don't need to do minus 0 in the calculator. And then I'm going to divide that by the square root. The square root acts like a parentheses. It covers everything. 7.8 squared over 30 plus 8.3 squared over 30. Your calculator understands order of operations. We get negative 2.4525. It doesn't matter what number of decimals you round to. I usually do 3, but I'm going 4 this time. All right, now I need to write down my DF, same one. We're going to add the word conservative at the top. And it's going to equal 30 minus 1, still 29. I need that for when I do TCDF. Okay, so let's draw a normal curve or T distribution curve. They look very similar. This will get us our p-value. Negative 2.4525. 1, 2, 3. Right there. And TCDF. Second bars, for me it's 6. Because I have shaded to the left and a less than sign in my HA, I start with negative 9 to the 99, or negative infinity. I put in my Z, or my T actually, negative 2.4525. And I put in my DF of 29. Paste. My p-value is 0.0102. I always round p-values to 4 decimals. And then now this last step is not different than anything we've done since we started chapter 9. Because our p-value is less than alpha, we reject HO, or the null. Because we reject HO, there is sufficient evidence to conclude that, and I just like to copy the question because they word it the best, beta blockers reduce mean pulse rate. All right, so as you can see, when we look at the whole problem, this is really similar to what we've already been doing. We have the same 4 steps, but we just have different formulas, even though they are similar style. They just involve different numbers. What you're going to do next is you guys are going to decide in this box on your paper if anything was confusing or if you need help with anything. Write it here, turn this in to Colonel Wind, and I can address it when I get back. Your homework is to finish the 2 sample inference worksheet. I'll check it on Wednesday the 20th. Email me if you have questions.